Good evening. Myself, Babu Ashok. Now I am going to share my views regarding the speed control of brushless DC motor. My paper ID is 34950. The paper title is Performance Enhancement of Brushless DC Motor under Different Novel Optimization Techniques. And my guide is Dr. B. Mahesh. So research motivation. As per global electricity statistics, induction motor consumes 46% line share of, which is replaced by energy efficient motors known as special electrical machines. Brushless DC motor is one of the above category, having several advantages. Soon it will replace IC engines in automobile industry by fulfilling the standards. Soon India can also emerge as electric vehicle capital. Research gap. Due to non-linearity in switches and payload variations in motor, degrades the performance and stability, henceforth induces error during speed control operation, which is the research hotspot. Research methodology. This research gives me meaningful insight. The buck boost converter acts as a bridge between supply and motor. The duty cycle is assigned by PA controller for closed loop control, and to ensure the performance optimization is popular in this decade, provides an avenue with PI controller to explore the selection of gain coefficients Kp and Ki. So some of the silent features of brushless DC motor. Merits. Maintenance is easier due to absence of brushes. So reliable, resilience, secured. Better speed torque characteristics, that is peak torque can be realized at near zero speed. Electric noise generation is low due to low dV by dt and di by dt. Lifespan is tenacious and outweigh demerits. Demerits. Control is complex and expensive, which is observed from quantitative and qualitative analysis from Scopus, Web of Science, Google Scholar, etc., spanning from 1980 to 2023. To ease these constraints, a novel attempt is suggested. Application. This is scalable, preferred in many low and medium power applications only, including wristwatches to water pumps, robot, hybrid electric vehicles, spindles, swinging bar, embroidery machines, aerospace, etc. So this is the general circuit diagram of the three-phase star mode brushless DC motor drive system. Here the DC is converted into AC by means of three-phase inverter, and this is the motor stator circuit, and this is the armature or rotor, which is having the permanent magnet. This is the buck boost converter, which can increase the voltage or decrease the voltage, which is having self-regulating power supplies based on the duty cycle. It is used in battery power system, regenerative braking modes, and it is applicable both conduction mode and discontinuous conduction mode. PA controller alone or buck boost controller topology with maximum number of components would put the clock back by year. So we are selecting with minimum number of components. So just next is comparative analysis of various modes of operation, attributes, continuous conduction mode and discontinuous conduction mode. Here I am preferring discontinuous conduction mode because voltage sensor is only one and the control is easy, filter requirement no, current trace is no, power factor is high, inductor rating is low. So based on the literature survey, I have arrived at a new solution where the buck boost, where only buck converter has 10 components, boost converter has 6 components, buck boost converter has 11 components, CUC has 13, SEPI converter has 13 components, CETA has 13 power electronic components, LU converter has 13 power electronic components, canonical switching cell has 11 components, Enhancement converter has 11 components. In my proposed bridgeless buck boost converter, I am having only total 9 components. By reducing the components, switching loss, conduction loss are reduced simultaneously, so thereby efficiency is increased automatically. Next, comparative analysis of selected topology based on survey. Earlier there were 3 methods: diode bridge rectifier, buck boost converter and bridgeless buck boost converter I am going to propose. Here the advantage is control is very simple compared to other 2 methods. Losses is very low. Efficiency is high. Power factor correction is near unity power factor is achieved. Cost is low. Here the sensing point is rotor split, unlike DC link capacitor. Next is total harmonic distortion is also very low. So next one is introduction regarding a conventional method. PA controller, fuzzy logic controller has its own limitation, that is inadequate rather than absolute. Erratic output during varying supply load or condition, more THD, which is uphill task to improve overall drive performance. Moreover, nonlinear VA characteristics of switches. These are the limitations of conventional converters. So this advanced method is reasons for optimization. Non-linearity due to switches, passive components, ambient temperature, tool to elevate the flight to maintain speed constant. Software-based control leverages overall performance. Easy implementation, parameters are measured on the screen. Data retrieval is easy, like pulse waveform or speed waveform. Monitor can be from remote places, so it's a new vista for global optima because optimization is vector in nature. Overview. In artificial intelligence, AI domain, nature-inspired techniques solve complex problems, continuous or discontinuous variables called as computational intelligence. Researchers believe this algorithm is brainchild of soft computing, benchmarked from different perspectives and constraints. It is based on animals or insects, food foraging behavior, which is used as searching mechanism. And this is the general block diagram. Single phase supply is filtered by means of LC filter and it is given to bridgeless buck boost converter. Thereby that AC is converted into DC. This DC is converted into AC by means of three-phase inverter and it is given to the brushless DC motor stator side. So that the excitation, stator excitation is based on the Hall sensor which gives feedback through the commutation logic. So another actual speed is compared with the reference speed and the difference between two is the error and that the error will be controlled as duty cycle by means of the controller which gives the duty cycle to the bridges buck boost converter. The first one is gray wolf optimization techniques. Here the hierarchy is 4 types. Omega are hunters, delta are supervisors, and beta are lieutenant or male, and alpha is the king. Whenever that in the absence of king, that beta will come into picture. The delta will act as supervisor and it will give guidance to the hunter wolf. It is based upon this equation. X of t plus 1 is equal to x of t minus a into c into cp of t minus x of t. During hunting, the gray wolves encircle the prey. The mathematical model of the encircling behavior is present in the following equation. D is equal to c into xp of t minus a into x of t, where x of t of plus 1 is equal to x of p of t minus a into d. The vector a is a random value in interval minus 2a, 2a, where a is decreased from 2 to 0 over the course of iteration. Where t is the current iteration, a and c are coefficient, xp is the position vector of the prey and x indicates the position vector of gray wolf. So this is how the gray wolves encircle the prey. When a is less than 1, that is the distance between the wolf and the prey is less than 1, the wolf attacks the prey, which represents an exploitation process. Next one is honeybee matching optimization. So it is fine-tuned by honeybee matching optimization, heuristic approach, because gray wolf optimization is comparatively slow. Here the QNB is the best solution, drones are incumbent solution, brutes are new trial solution, iteration until set speed is achieved. Here in the nature, queen bee survives for only 6 months, worker bee survives for 6 years, queen bee lays eggs and drones act as father. So this is the behavior of the honeybee. Here in the list there will be one drone will be selected in random, that is selected as a father, and that queen bee will mate and it will produce a brood. Brood means here solution. Here and it will be compared and that selected brood, if it reaches the desired speed, then it will be acting as the queen bee. Otherwise, it will be go for another mating. Like this, the cycle will continue. So this is the probability equation of the queen and drone. So delta F represents the absolute fitness difference between the queen and the drone. As the mating flight continues, the queen's energy and PK decay starts decay simultaneously after each iteration. So this is the energy level. Energy T of plus 1 is equal to alpha into energy into T. The T ranges 0 to T and the decay rate is 0 less than infinity, which is less than 1. When speed T of plus 1 equal to energy T of minus beta, where T is 0 to T and decay rate beta lies within 0 and 1. Queen means highest weightage in the cluster at the current instant. Drone means lowest weightage. So this is drone is subjected to vary depending upon each iteration. Next one is advanced optimization, that is artificial immune system, AIS. Next one is FLG, frog leaping guided algorithm. So this is the flowchart for artificial immune system. You have to initialize the population, threshold value, antibodies, objective function, antigen. You have to generate a clone set C and mutate each clone. You have to compare individual value of threshold. If it is low, then that clone set is removed. Otherwise, if it is high, place in P and insert random individuals. If thermal condition is met, then the result will be displayed. If it is no, it will be go back to the original position. So these are the steps. That is, antibodies will be generated according to the antigen. So here that antigen will be nullified. Next is frog leaping algorithm. Here that frog will be initialized in that cluster. So placing frogs in M subpopulation, that iterations will be repeated in such a way that whether it reaches maximum iterations and it will give a unique global optima results, then it will be displayed. Else it will be go for initial step itself. So I am going over testing. This is 25% load for 1500 RPM. Here you can see that frog leaping guided algorithm shows minimum peak overshoot and minimum settling time. Similarly for 50% load, and this is for 100% load, and this is 100% load for 1500 RPM. So these are the total harmonic distortions. You can see that frog leaping guided algorithm shows minimum THT, 70% load, full load, and these are the performance for constant loading. That is 25, 50, 75, 100. You can see that frog leaping guided algorithm shows optimum value, better result than the other three value. Next is step changing load. Step changing load means the industry it will be varying load. So in that condition that it is tabulated 0 to 25%, 0 to 75% of the maximum load, then 50 to 100%. It also inferred that frog leaping guided algorithm has optimum value. That is minimum peak overshoot settling time and total harmonic distortion, but power factor is comparatively high. Next is variable speed. Here also the speed is varied after 1.5 second or 1 second. From that, it is inferred from the tabular column that frog leaping guided algorithm shows better results than the other two. So this is validated with an hardware. These are the design equations pertaining to it. From the design equations, I am arriving these parameters. From that, based on the parameters, this hardware is found. As the single phase supply is converted to converter and it is given to Arduino controller, and that DC is converted to AC by 3-phase inverter and given to brushless DC motor. From the feedback Hall sensor, this will be given to the Arduino controller, which will assign the duty cycle accordingly. This is setup for hardware setup. So these are the results of frog leaping guided algorithm. This is the performance during Honeybee mating optimization, artificial immune system. Whereas frog leaping guided algorithm gives much better result. That is load increasing the load, there is only minute drooping characteristics when compared to the other. These are the hardware results for 25, 50, 25, 100. Here that frog leaping guided algorithm shows optimum value for all the loaded values. So I am comparing the simulation result and hardware results for Honeybee mating optimization, artificial immune system, and frog leaping guided algorithm. So frog leaping guided algorithm gives comparatively better results than the other three methods. So this is the power quality matrix, total harmonic distortion power factor. Here frog leaping guided algorithm gives maximum power factor and the total harmonic distances is minimum, this rose color value. Similarly, time domain specification, peak overshoot. Here the peak overshoot is comparatively minimum frog leaping algorithm, settling time also minimum. So if this peak overshoot settling time is minimum, means that wear and tear across the machine will be less. So the lifespan will be more. If total harmonic distortion is less, means heating is also very less. If power factor is improved, means then the current drawn from the electricity supply is also minimum. So settling that electrical billing will also be reduced automatically. So from this, what I conclude is that frog leaping guided algorithm is better than grey wolf honeybee mating artificial immune system for various testing conditions. And the result is power factor improvement is 7%, total harmonic distortion is reduced by 20%, peak overshoot by 60%, and settling time is reduced by 60%. So that the error is minimum in frog leaping guided algorithm. This is suitable for low power applications. So these are some of my key references. Thank you, sir.